Now we are going to study question from March 2019 exam, question 2. Now we are going to study question from March 2019 exam, question 2. Okay. March 2019 exam, question 2. Okay. Try to see the scenario, guys. Very nice question. We are going to learn a lot of things in this question. So try to see the scenario here. What is they have given in the question? A body can be hauled up. Okay. See the scenario. Okay. A body can be hauled up on an inclined plane at a constant velocity. Okay. Body can be hauled up. Hauled up means body is going up on an inclined plane at a constant velocity by a 2.5 kilonewton force applied parallel to the plane. Okay. See the point here. The same body can be lowered with a constant velocity by a force of 150 Newton applied parallel to the same plane. Okay. And if the plane rises 1 meter. Okay. See the scenario. Plane rises height 1 meter in a height of. Okay. See the last point. If the plane rises 1 meter in a height. Plane rises 1 meter in a height for every 5 meter of length. Okay. See the point here. Okay. Now, first of all, I am going to explain this last sentence of this question. Okay. See, if the plane rises 1 meter in a height of for every 5 meter in length. Okay. What does it mean? Okay. What does it mean first of all? And then I am going to read the first paragraph once again. What does it mean, guys? They have given that sentence for what purpose? See, what is the meaning of that sentence? Okay. This is what our plane. This is what our plane. So, plane rises 1 meter in height. Okay. So, this will be the height of the plane. This will be what, guys? What will be the height of the plane? 1 meter for 5 meter of the length. Okay. Means plane rises by 1 meter for a 5 meter length of the plane. Okay, guys. Are you getting my point? Meaning of this sentence? Okay. So, what is the meaning of this one? By using this one, we can find out what we can find out, guys. We can find out alpha. See, I am reading once again. If the plane rises 1 meter in height for every 5 meter of length. Okay. Means when the length of the plane is 5 meter, it rises by how much, guys? It rises by what? 1 meter. Okay. So what does it mean? From this one, what we can calculate, guys? We can calculate alpha. So here, this is what our angle. Opposite is what? 1 meter. 5 meter is what? Hypotenuse. What is the relation between opposite and hypotenuse? Sine. So sine alpha will be equal to what, guys? Sine alpha will be equal to what? 1 by 5. 1 by 5 means what? 0.2. So alpha is equal to what? Sine inverse of what? 0.2. Okay. So sine inverse of 0.2, everyone. How much, guys? 11.5369 means we can take 537. Okay. So we got it alpha. Okay. You got this meaning of the sentence. Okay. First of all, guys, write down this one. Okay. Then we will go further. Okay. Just first of all, write down this one, everyone. Now, guys, try to see the scenario here. So this part is what? Only for the alpha. And how much alpha we got? For my reference, I am writing how much we got the alpha, guys. 11.537 degree. Okay. Angle of the plane with respect to horizontal. Okay. Now, I am going to read the first paragraph of the question once again. Okay. So, I am going to read the first paragraph of the question. A body can be hauled up. Okay. See the scenario here. A body can be hauled up. Okay. So, here we have a scenario, guys. Try to see the point here, everyone. So, this is what our, guys, our plane. This is what on our angle alpha. Okay. See the point here, everyone. Don't do anything. Don't write anything. Okay. This is what our angle alpha. Okay. This is what our body. This body is visible to everyone. Okay. 1 minute. Okay. Now try to see the point here, everyone. Everyone try to see the point here. What we needed, guys? What we needed here? So a body can be hauled up by an inclined, hauled up on an inclined plane at a constant velocity by a 2.5 kilonewton force, okay, applied parallel to the plane. So here we are applying what, guys? We are applying a one force, okay. Which force we are applying? Which is what, guys? Parallel to the plane. Okay, this is what a force we are applying. Okay, so what we will say, 1 minute, guys. Very huge angle. This is what our alpha, this is what our body. See the point here, everyone? Don't write anything, don't draw anything. So, we have a force which is parallel to the plane. Force is what? So, this is what a force. How much is the value of this force, guys? How much is the value of force? How much is the 1.5 kilonewton means what? We can take it as a 2.5. Okay, so that will be what? 2500 Newton. Okay. Now, okay, we don't know weight of the body. What will be the weight of the body, guys? Okay, we assume mass as a m. So, what will be the weight? Everyone, what will be the weight? mg. So, weight will be what, guys? Everyone, try to see the scenario. Weight will be what? mg. Okay. Guys, are you getting my point? Try to see the scenario here. This is what our body. And this is what our force which is parallel to the plane. And that what we will say as F1, that is what, a 2500 Newton. Okay. Now here there will be what, guys? Normal to the reaction will be there. Normal to the plane. So this is reaction, what we will say? Rn1. Okay. Then there will be what, guys, here? A friction force will be here. Body try to go up. So friction force will be what? Opposite to the motion. Okay, everyone. So this friction force will be how much, guys? Fr1. Okay. Now, okay, this is the one scenario. Okay. Now what about other scenario, everyone? What about other scenario? Okay. Now I am going to read the further. The same body, what, guys? The same body can be lowered with a constant velocity. Okay. What we are doing? We are lowering the body, same body lowered with a constant velocity by a force of 150 Newton parallel to the plane. Okay. Now I am drawing the same object. See the scenario here, guys. Everyone, don't write anything, don't draw anything. This is what our plane, angle alpha. Then this is what our body. Okay. Now here what we are applying? We are applying a force F2. And what is the value of F2, everyone? 150 Newton. What is the value of F2, guys? 120 Newton. And then there will be what? mg. Then there will be what here? Normal reaction. Normal reaction is what, everyone? What will be the normal reaction? Rn2. And here body is going down. So what will be the scenario? There will be what, everyone? Okay, friction force. And what we will say? Fr2. Okay. So this is what they have given, these two scenarios, everyone. Try to observe these things. Okay. Now just what you have to do? Try to draw this drawing, both the drawings side by side, guys. Everyone. Everyone try to draw both the drawings side by side, first of all. Side by side, everyone. Side by side, try to draw the drawing side by side, everyone. Now guys, try to see the scenario here. What we have to find out here? What is our target here? Okay. Now what they are asking us in the A part, guys. Try to see the scenario. What they are asking us in the A part. Sketch the force diagram for the body being hauled up on the incline. Okay. So this drawing is what our A part, our answer. Okay. when hauled up in the incline. Okay, but we need both the drawings. Okay, so we are drawing both the drawings. Okay, we are drawing both the figures. Okay, now what they are asking us in the B part, calculate the mass of the body. Okay, what they are asking, you have drawn both the drawings side by side. Now we have to draw both the drawings side by side. Now everyone, these drawings, both the drawings must be side by side. Okay, now here, see, try to see the scenario here, everyone. Here velocity is what? Constant. Here both the scenario, in both the scenario, what is constant in both the scenario? Velocity is constant. And if the velocity is constant, what it means? Okay, it is in equilibrium. Now guys, here try to see the x and y direction. This is what our x direction. This is what our y direction. But in this scenario, which x direction we will consider? This is x direction. And this is y direction. Okay, try to see the x direction here. X direction always along the plane and in the direction of motion. Guys, remember this point. X direction is what? How we have to select x direction? Because after this we are going to start a new chapter, linear motion. Okay, in linear motion means in always, guys, remember x direction is along the plane and in the direction of motion. Okay, so here motion direction is what? What is the direction of motion? This is the direction of motion. Okay, try to see the point here, everyone. Okay, so as x and y direction, so x is along the plane in the direction of motion, because here motion is what? Motion is upward. Try to see the point here. What about this one? Here motion is downward. Downward along the plane. Okay, now try to see the point here. So this, for this 100G, what we are going to do? We are going to form a rectangle like this. Sorry, not 100G, my mistake. For this mg, we are going to form a component. And how we are going to form a component? Guys, how we are going to form a component? One is, okay, this is one component along the, perpendicular to the plane, and another component perpendicular to the plane. Everyone, try to see the point. Everyone. So this will be what? This angle will be what? Alpha. If this is alpha, this will be alpha. So this is what? Mg cos alpha or sin alpha? Sin alpha. And this component will be what? Mg cos alpha. Same story will be here also. Same story here also. Please everyone, try to observe the things. Okay, so what will be the scenario here? This will be one component perpendicular to the plane. Okay. This will be another component parallel to the plane. This angle will be what, guys? Alpha. So this is what? Mg cos alpha. And this is what? Mg sin alpha. Okay. Now try to see the scenario here. As usual, we are going to start with what? What we will start here? We are going to start with what, guys? Summation of forces x and y direction. Okay, both are equal to 0 here. Okay, so first of all, as usual, our favorite story is what? We are going to start with summation of forces in y direction here. Why? Because we first of all going to find out. So here, summation of forces in y direction. Here, what are the forces here y direction, guys? What are the forces here y direction? Rn1 equal to 0. So what are the forces Rn1? What will be next, guys? Rn1. Okay. So minus mg cos alpha. Okay. Equal to 0. So Rn1 will be equal to what? M into g is what? 9.81 into cos alpha. What is the value of cos alpha, guys? 11.537. So what will be the value of Rn1? We will get in terms of m, guys. What we will get? We will get value of Rn1 in terms of what? M. Okay, 9.81 multiplied by, everyone, 9.81 multiplied by what? Cos of 11.537. How much, guys? 9.8 m. Okay, so we got Rn1. Okay, try to see the scenario. Then what will be the next point here? Fr1. What will be the Fr1 here? Guys, mu Rn1. Mu is unknown to us. Okay, see the point here, everyone. Okay, mu is what? Unknown to us here. The next story is what? So mu is unknown to us. Okay. Summation of forces in what? Everyone. Summation of forces in what? Y direction equal to 0. Okay, what are the forces Y direction here? First of all, what guys? F1 minus Fr1. Okay. F1 minus Fr1 and then minus mg sin alpha. Okay, try to see the point, equal to 0. So Fr1 will be equal to what guys? F1 minus mg sin alpha. Okay, try to see the point here. Okay, so what is Fr1 will be what? Mu into how much Rn1? 9.6118 m. M is a mass, not a meter. Okay, so we got Fr1 in terms of what guys? F1 minus mg sin alpha. Okay, same story we are going to deal with this one. Okay, don't write anything, don't do anything. We are going to take a summation of forces in which direction we are going to take? Summation of forces as usual, y direction equal to 0. What are the forces here? Y direction. Rn2 minus mg what? Cos alpha. So Rn2 will be equal to what? M into 9.81 into cos of alpha is how much guys? 11.537. So if you observe these both the terms, this one and that one, it will be same. Rn1 and Rn2 will be same. So what will be the value of Rn2? Same here, 9.6118 m. So we got, what we got guys? What we got? We got Rn2 in terms of m. See, both Rn1 and Rn2 is the same. Now what will be Fr2? What will be Fr2? Mu into what? Rn2. So Fr2 will be equal to what? Everyone? Mu into, and here plane is the same. Here plane and the object is the same. So coefficient of friction will be same. So for this scenario and for this scenario, so coefficient of friction is the same. So Rn2 is what guys? Everyone, 9.6118 m. So what we got? What we got everyone? We got Fr2. Everyone try to see the scenario. Now if you observe this one, try to observe the scenario. This Fr1 and this Fr2. What is the speciality of these two? Try to observe this both this scenario. And this one. What is the speciality of guys both the cases? What is the similarities then? Same guys. Here mu, here mu. Here 9.6118. Here also 9.6118. Here m. Here this m is not a mass, not a meter. This m means what? Mass guys. This m means what? Mass. Here is also m. So Fr1 is Fr2. Then again same. Summation of forces here what? Summation of forces in y direction equal to what guys? 0. What are the forces here? Y direction. What are the forces here in y direction here guys? Sorry, x direction. X direction. Okay. So here what we can take positive? F2 we can take positive because here we assume this is, see, always x direction is along the plane and in the direction of motion. So F2 plus mg sin alpha minus Fr2 will be equal to 0. So Fr2 will become equal to what guys? F2 plus mg sin alpha. Okay, please everyone write down these things below this drawing. Below this drawing write down these things, and below these drawings write down these things. Everyone please. Okay guys, completed. You have written this, all these things means below this drawing you have to write down all these things. Below this drawing you have to write down. Any doubt in this discussion till now? Okay guys, we are nearer to our answer. Okay, so try to see the scenario here. Now guys, our final answer. Okay. Now what is the same here, guys? What is the same here? Okay. FR1 is equal to what? FR2. FR1 is equal to what? This is what our FR1. Try to see the point. This is what our FR1. This is what our FR2. Okay. So FR1 is equal to what? FR2. Okay. Now what is the expression for FR1? F1 minus mg sin alpha. What is the expression for FR2? F2 plus mg sin alpha. Okay, guys, try to see the scenario here. Okay, everything is okay up to this point. Okay, so we are going to shift mass on that side. So F1 minus F2. So this will become this side mg sin alpha plus mg sin alpha. Okay, everyone. Everything is okay up to this point. So this one, F1 is how much, guys? F1 is how much? What is the value of F1? 2500 Newton. F2 is how much? 150 Newton. This will become 2 times mg sin alpha. Okay, so 2500 minus 150, 2350. See the point here. We are nearer to the answer. 2 times m into g into sin alpha. Okay, so m will be equal to what, guys? 2350. Okay, everyone. So what will be the value of mass? M 2350 divided by what? 2 times g is what? 9.81 sine of into 11 point how much? 537. Okay, guys, are you getting a point? Try to see the scenario here, and in this way we will get the mass. How much mass value we will get? Please do the calculation. Everyone, please do the calculation. Okay, 598. So how much value of mass we are getting? 598 point how much, guys? 877. Okay, so or I will write down here. So I don't have a space here, so I will use this space. So how much mass we are getting, guys? 59877 unit mass. Mass. It is not a Newton, guys. Mass in kilogram. Okay. So this is what our answer of B part. Okay. This is what our answer of B part. That is what they are asking in B part. Okay. This drawing is our answer of A part. Okay. So after writing this, up to this FR1 and FR2, you have written side by side, na, guys? Okay. Okay. After that one, guys, leave the one line. Okay. Or mark the one line. And after that, start writing down this up to here. Guys, what they are asking us in C part? What they are asking us in the C part? Try to see the scenario. What they are asking us in the C part? Coefficient of friction. What they are asking us in the C part, guys? Coefficient of friction. And how to find out the coefficient of friction? See the scenario. Okay, mu they are asking us. Okay, now here what they have? We have expression FR1 is equal to what? FR1 is equal to what? F1 minus mg sin alpha. Okay, try to see the scenario. What is meant by FR1? Mu into 9.611. Okay, see the scenario. 9.6118 m. F1 is how much, guys? How much is the value of F1? 2500. So 2500 minus m. Okay, or just I will keep it F1 here first of all. Mg into what? Sin alpha. So we need what, guys? What we need? We need a mu. So mu will be equal to what? F1 minus mg into sin alpha divided by what? 9.6118 m. Okay, so mu 2500 minus m. M is we just now calculated. 598 point, how much guys? 877 into 9.81 into what? Sine of how much? 11.537 divided by what? 9.6118 into 598.877. Okay, please everyone do the calculation and tell me the value of mu. 0. How much? 0.23. Okay, so we got the value of mu. Okay, any doubt in this discussion? So this is what our answer of C part. Okay, very simple question guys. Okay, just a twist of this question is what? Here x direction downward along the plane, here x direction upward along the plane. Okay, that's the only twist. And just we equate FR1 and FR2, and from equating FR1, FR2 we got the mass m. By equating FR1 and FR2 we got the mass m, and by using mass 1 we calculated mu. Okay, that's the simple story. Please everyone write down this point.